Benvenuti. Oh, fantastico. Benvenuti a tutti. Mi fa piacere poter ospitare la vostra community all'interno di questo spazio Microsoft. Questa è la sede Microsoft italiana. Questo piano è completamente dedicato a eventi, quindi più che benvenuti, è dedicato a eventi dei nostri clienti, dei nostri partner e anche di gente come voi che ne sa a pacchi, come si usa dire. Lascio la parola a chi ne sa veramente, oltre a ringraziarvi, rinnovo il benvenuto. Tanto io sarò qua fino a dopo, quindi volentieri ci sentiamo.
Grazie mille Roberto. Grazie mille Roberto e a Microsoft per l'ospitalità in questa splendida venue. Siamo molto contenti di essere qui con la nostra quarta puntata del Meetup di PyData. Faccio una brevissima introduzione per chi non è mai stato, cioè chi è che non è mai è la prima volta che viene al Meetup? Non ci sono poche persone. Allora, PyData è una comunità di sviluppatori utenti di tool per data scientist e data engineer open source. Nasce da una non profit americana NonFocus che si occupa, oltre ad organizzare la comunità, di supportare progetti open source. È stata creata dalle persone che hanno creato NumPy, Matplotlib e tutto l'ecosistema iniziale in ambito data. E è presente in diversi paesi al mondo e ci sono adesso 6 chapter in Italia. Una delle cose particolari di PyData, che uno dei suoi valori è anche legato all'aspetto di diversità, perché c'è la convinzione che una comunità più diversa crea un sistema, un ecosistema più robusto, più vario, più ricco. E tra gli elementi che aiutano a far questo c'è il fatto che bisogna comportarsi in maniera professionale e gentile con tutti quanti, in modo che tutti siano benvenuti. Solitamente organizziamo gli eventi il terzo mercoledì del mese. Questa è un'eccezione, nel senso che ci siamo dati come data di default il terzo mercoledì del mese, ma a seconda di disponibilità di venue e di speaker ci adattiamo, quindi a questa edizione siamo così. Il prossimo evento classico Meetup sarà a settembre e c'è una call for speaker aperta per proporvi per venire a parlare per gli eventi da settembre in avanti. Ecco, cosa importante, Paolo ci sei? Dov'è che sei visto? Che magari conti adesso il dinner, perché quindi uno dei momenti che ci piace molto fare del meetup è, con chi vuole e chi ha la possibilità e il tempo, di andare a cena dopo in un posto qua vicino. Quindi chi è che è interessato a venire a cena? Ok, e così adesso abbiamo il numero e aggiorniamo la prenotazione. Per venire a parlare il Meetup è un luogo, proprio se uno non ha mai fatto talk in pubblico, molto adatto, perché tendenzialmente non è che c'è ci sono dei paletti da superare una selezione, come per esempio nelle conferenze, che invece ultimamente c'è sempre un sacco di proposte e non è facile avere una proposta accettata, quindi Meetup è uno dei luoghi proprio adatti per iniziare a fare una talk, che poi magari uno vuole proporre una conferenza, e per iniziare a parlare di qualcosa, di una libreria, di un caso d'uso, di qualcosa che può interessare alle persone interessate all'ambito PyData, che tendenzialmente sono data scientist e data engineer. E il passo successivo, se non l'avete già fatto, potrebbe essere andare a una conferenza e proporre qualcosa a una delle conferenze. Ce ne sono diverse tra luglio e settembre, tra Praga, Eindhoven, Amsterdam e Parigi. Il meetup di PyData Milano nasce all'interno dell'organizzazione di Python Milano, che è invece un meetup, noi siamo nati a gennaio, ma siamo parte di Python Milano che ha più di 10 anni, ha fatto 10 anni a luglio dell'anno scorso. È più vecchio in particolare di Kubernetes, il meetup di Python Milano. E insieme al meetup di Python Milano, a luglio, data da confermare il 10 luglio, organizziamo invece una cena libera, solo la parte cena, che è oggettivamente la parte che ci piace di più. Grazie a Python Italia per il supporto che dà Python Milano e a Division Lab per il supporto video che ci permette di andare in streaming e registrare. E quindi direi che adesso do direttamente la parola a Marco Vinciguerra e Marco Perini, che ci parleranno di ScrapeGraph AI, You Only Scrape Once. Un caloroso applauso di benvenuto.
Grazie. Okay, I'm gonna switch to English, so because we are streaming, we are like streaming live on YouTube, so also for the other people on from home, let's say. Okay, I will switch. I will switch. So, okay. Okay. Hi everyone, I'm Marco Perini, and I'm here today to present ScrapeGraph AI, which is an open source project which we started like 4 months ago as a joke, and then we are here today because it became something suddenly. And we are a team of 3 people, Marco Vinciguerra, which is the other speaker here today, which is a computer engineering student at University of Bergamo, Lorenzo Padoan, which unfortunately today isn't here, but is in Brussels to present one of his papers about generative AI. So it will follow in remotely. And myself, which I have a master's degree in mechatronics engineering related to robotics and AI. And I'm currently working on at a research center in Bolzano to things related to generative AI about buildings.
Marco, can I interrupt you for a moment?
Yeah.
You're sharing the presenter mode and not the other screen.
Okay.
You need to go to
Swap
no, to
no?
No?
No.
You can swap again, and then we just need to change in the web browser Video Ninja.
Mm-hmm.
Ok. E farei questa.
Cosa?
Prova un attimo se è screen. Consenti start.
Forse proviamo direttamente su
PowerPoint.
PowerPoint.
Proviamo a fare.
Mm-hmm.
Così. Proviamo a fare refresh un attimo di questa. Share your screen. Mm-hmm. Select screen to share. Select screen, qua, scusa. Questo. Schermo intero. Solo che adesso te ne fa vedere solo.
Magari mostro solo questo.
Ok, va bene, facciamo così. Speriamo. Vediamo. Facciamo una prova. Com'è Luca? Siamo ancora su presenter mode?
Sì.
Facciamo un attimo di nuovo un... Adesso che sei in presenter mode, tienila in presenter mode e prova a fare di nuovo un refresh. Sì. Quindi facciamo il volo. Share screen. Schermo intero. Ok, perfetto. Ce l'abbiamo.
Ok, è comparso.
Ok.
Ok. I will not. Thank you. Okay, I will not start again, but I finished that. I'm working as a research engineer at a research center in Bolzano called the UREC Research, and I'm developing generative AI solution related to buildings. So to describe buildings in a better way, in a more structured way. Okay. Nowadays, you know more than me that data is the new oil. There are basically businesses that build around data. They sell these kind of services. And with this, we can do a lot of stuff, such as analytics. We can analyze trends. We can understand how people move, what they buy, to better and better, like make some adjustment to the products to give to people and clients. And to also create new services. For example, if we know that a lot of people, maybe German people go to Venice, and maybe some other regions want to understand why there are so many German people go there. Data, it's a really powerful tool to understand this. Maybe there's some contemporary museum in Venice, so it's better like to build some similar like that also in here in Milan, for example. And also data are really important also for training of large language models, which is a hot topic in these days. And it is proved that it's really important to have high quality data, which are very important to create better and better models. And also hot topic is a knowledge graph, how we connect entities together to compare them and getting better and better insights from this data. And of course, the main source of this data, what is? The World Wide Web. And most of that can be found online. And that's why companies are pushing to find some ways to retrieve this data in the most efficient and fast way. One of the ways to do that is by a tool called the Scraper. Scraping is the act of extracting information from different sources, such as websites, but also local documents, private documents, such as PDF, XML, CSV. And there are different tools which we can use to do that. But more traditionally, these tools do not use AI or large language models, but are used by really experienced programmers to create programs to extract this information. Some of these tools are, for example, Beautiful Soup, Scrapey, and there are also some web services built around it, such as Web Scraper and Octoparse, which uses these tools to scrape data from different sources. For example, we can do that by selecting the elements we want to get from the website and create a template from the things we want. And these services will tackle all the rest for you. So we came up with this question: if it was possible to scrape websites or local documents without any knowledge of HTML or like structure of underlying structure of different documents, and just by writing what I want and how we want. So we came up with the ScrapeGraph AI, which is an open source Python library that allows people to scrape content from websites and local documents using large language models. So just by defining a prompt, so for example, asking what we want. For example, if we are in a news website, we want all the news with their description, which we can just ask, give me all the news with their description, and you don't need to know how to code, let's say, and how HTML works under the hood. It is highly modular because there are different types of feature in the open source Python library that later on Marco Vinciguerra will explain. So why ScrapeGraph AI, SG AI? So Scrape, of course, because we extract information from the web, from private documents, and Graph, because we use a graph engine. So, for example, there are many types of nodes connected to each other. Each node has defined a function. These functions are connected to each other and share a state, which can be the information elaborated over time. For example, the first node could be the node that fetched the HTML from the web source, the second one to parse all this information from the HTML, and the last one maybe a node that can use large language models to understand what's in the data. And by using this structure of SGraph, we can also create loops and do this sort of stuff. And AI, because it's the first thing that comes to our mind when we decide to use AI in one of our projects, is because why not? Because actually that's how it is. But actually we use AI, we use large language models. So this is the traditional workflow for scraping. So first of all, you need to understand how HTML works and find the CSS selectors of the elements you want to get to extract. Write some scraping script, for example, using Beautiful Soup or other, and then start scraping, cross finger. Let's hope that the next time that we scrape the same website, we don't get any errors, because it may change dynamically the structure of the HTML. So we need also to write a custom code for each website, which is time-consuming, and it requires also a lot of time for an expert to do that. Instead, ScrapeGraph AI workflow, we just input an URL or a source, so a local document. We ask what we want to scrape, and it will start scraping right away. And this way, it's able to adapt to changes of the structure of the websites, and it corrects itself until it succeeds. So if there are some errors, so if the output of the LLM is not correct, it's not a perfect JSON, then it will retry till you get one. And then, of course, it's really flexible for scraping a different website, because you don't need to write again the script from zero, but you just change 2 lines of code with the URL and what you want to scrape. Available large language models that are in the Python open source Python library that you can use. So ScrapeGraph AI is basically a tool, and this tool can be used with many large language models. You can choose from Azure, OpenAI, Grok, Google ones, Microsoft, and also we support local large language models, so you can run your large LLM on your machine, so you preserve your data, and you don't need to have also internet connection if you want to scrape local documents. So this is like our start history on GitHub. It's like a skyrocket in May. Like in less than 1 week, we got like 8K stars, and we started the project in February, and it keeps growing. And our aim now is to reach this other repo called Anime Girls Holding Programming Books that contains only a picture for each programming language with an anime girl and holding a book. So we're almost there, basically. But yeah, jokes aside, we've been featured on many platforms, LangChain, which is the engine we're using also. Hacker News, people wrote some articles on Medium, Market Post. We've also been trending on GitHub, and also been featured on Python Weekly newsletter. So
Alpha Signal also.
Yeah, Alpha Sigma is a really good newsletter service about AI. And yeah, we also went to GDG in Venice to present the solution. And when we went there, like 1 month ago, we had really few stars, 1,000 stars and less. Yeah, so these are the numbers. So now we have 12+ K stars on GitHub, 900 forks, more than 100K downloads on PyPy, and more than 500 users on Discords that keeps asking us stuff, writing on the support channel, and yeah, we are helping them, and they are also helping us to understand what they really want. These are also all the contributors that helped us over this period, like developing new features and filing issues on the GitHub, PRs, and so on. And that's how we, thanks to them, we kept growing and implementing new feature and understanding what the actual community wants. So now we'll leave the talk to Marco. That will explain more the technical specification of the library.
I'm the other Marco, and I will talk about the technical specification, in particular how the library components are present in the library and how they are made. First of all, we have to start with the nodes. The nodes is the basic component of our library, and as Marco showed before, basically the library is a concatenation of nodes and it could be like a kind of chain where every node has a specific role. For example, the fetch node is the node who takes from the internet and documents and fetch the content and put in the state. Basically, from one node to another node, we pass the state, and the state is updated at every node. And instead, the parse node, given a document in a state, it will split in chunks in function of the model token and the context window of the artificial intelligence that the user wants to use. The RAG node chunks the vector stage and makes the retrieval. The generate answer node is the node who is specialized in creating the reply using LLM models. It could be whatever models you want, and you have just to specify in the main. Other nodes, relevant nodes, are search internet that search on the web the information that you want to have, given a prompt, just a query. And text-to-speech node and image-to-text node are related to OpenAI services. In particular, text-to-speech, read and return an audio file. Okay, and the graphs are concatenation of many nodes. In particular, the smart scraper, each node has a specific function for making a specific action. In particular, the smart scraper node is the most used one, and given a prompt and a link, it will return you the JSON in the JSON format, the reply to your answer, basically, using LLM models. The search graph is a graph who makes a multi-search engine scraper that, given a query, it will find on internet the top X results and retrieve them and return the best answer that you need. The script creator graph is similar to the smart scraper graph. It just changed the last node, and the output is not a JSON anymore, but a script in beautiful soup. In my opinion, this is the most important graph that we did, because it would be used for scraping pipeline for big scraping industries. In particular, when there is a fault, you can create in just 1 minute the new script that will be used for the next iteration for the scraping pipeline in the company. The OmniScraper graph is for OpenAI models, in particular GPT-4o, and is a one-page multimodal scraper. And the speech graph is a scraper that return an audio answer. Okay, let's start with the basic one, the smart scraper graph, and is just a concatenation of nodes. In particular, the input could be a URL or a local file, so you can download by yourself the HTML if it is difficult to retrieve, or is it in a local host. And you can add the user prompt, and eventually, if you use an external service, you can add the key, for example, for OpenAI or Gemini. Instead, if you use Ollama, you don't need the key. And in the first part, there is the fetch, where you get from the web or your local file the code that you want to scrape. It is parsed in documents and is stored in a RAG database. For each RAG document inside the RAG, you invoke a LLM model for creating the JSON answer. Basically, this is the pipeline. For example, you would like to, given this link that is probably weread.com, you want to take the title and the short description, and you have just to in the demo, I will show you that you have just to change 2 lines of code from the example that are available on the library. Okay, this is the search graph that, and basically is very similar to the previous one, but use some instances of the smart scraper graph. In particular, the first part is a search on Google or Bing or whatever website you want. And after it's retrieved, for each website, you invoke a smart scraper in parallel, and is not sequential. So you can make multiple research in parallel, and after the content is merged for a JSON answer. And the other graph is the script creator graph, and it's very similar to the smart scraper graph, but the last node generates the code in the Beautiful Soup or whatever library in Python for scraping you want. Okay, and this is an example of a use case of speech graph. In particular, it could be used for creating an audio answer. First of all, you have to concatenate a smart scraper graph with a text-to-speech node. And after the script is done, you will have the result read by an AI. The RAG node is used for retrieving the most current web pages based on the user prompt, and this is stored in a vectorial database. Okay, and basically, if you want to have the answer in a specific format, you can also specify the type and the schema that you want. In particular, you can use pedantic classes for specifying, for example, the title and the description if you want in an output in this way, in this specific format. And it's very easy because after you create the classes, you pass it in here in the smart scraper graph. And in this way, you specify the format of the output. Okay. For retrieving the information on internet, we don't use Selenium or Scrapy. We use Playwright because, thank you, Microsoft. Because basically, we use that because it was, I think, with a good community, and it was easy to overlap Cloudflare and cookies, and it was also possible to set a timeout for a specific website that are too tricky for extracting the content from internet. Okay, now we will make a comparative experiment. For example, we want to scrape this website. We usually, come back please. We usually use this website because it's very heavy, and it has a lot of bunch of stuff, a lot of articles. So it's our benchmark. Don't tell to Wired that we use them. Okay, this is the classical method. In particular, you have to, as Marco showed before, you have to specify all the CSS selectors for extracting the content, and it's very boring because we don't like to open the browser in editor mode, read all the code, find the selectors. Boring. Instead, here you have just to copy paste from our example and change, add the API key, add the prompt and the file source, that is the website, and the game is done. If you want, we can make a short demo. Can I switch to my computer?
You want to finish and then show the demo?
Before.
Okay. Wait.
Riesci a spostare il tuo?
Okay.
Okay. Basically, this is the example in our pipeline. And as I showed before, As I showed before, this is basically the whole code that you need for doing the scraping with our library. And first of all, you have to make the graph configuration, and you have to specify the model and the API key. And after, you just write the prompt and the source. We can make a trial if everything works. I hope so. Yeah. Python. Okay, here are the. Okay, now there is the generation of the answer, and in 10 seconds you scraped a website. And let's go back to the slides.
No.
These are our.
Oh, wait. Aspetta, non si... E non va avanti con le slide. Tipo... Okay.
Okay. Okay. The pros of using our library, as you looked before, and is that you have low code to write, and the implementation is very fast. And the other advantage is that it's fault tolerant, because there are some websites like Amazon that they don't want that you scrape them, and they change the CSS selector over time. So basically, your script is good, works for just 1 or 2 times. After that, is broken, and you have to fix it. You can use local models, so they are free to use, and you can use on your laptop. The portability, and if you want to use local model, you have data privacy preservation, and we have a big community that helps all the people that want to start with our library, and help to grow up as. This is our benchmarks, and this is on the beta branch, because we didn't put it in the main right now. In particular, we have, with my MacBook, in 16 seconds, you scrape this website. But the most important result, I think, this is with GPT 3.5 Turbo as a provider, because it's very cheap in than the others, and it works well. Sometimes he don't want to reply you. I don't know why. Maybe because he's bored to reply to your answers. But that's it. We are also having a kind of collaboration with this library that works for YC. And you can see how the state evolves over the time. It's a kind of debugger, but it's quite cool to have it integrated. And these are our repositories. In particular, this is the main one. And this is the organization. And if you like that, you can leave a star and help us to grow, maybe. And our roadmap is to implement the deep search graph. That is a new graph that basically you ask an answer, and it finds on the page on the website and change the page by himself, given a path. So you, for example, if you go to our website and you don't have on the main page the contacts, or for example, of a restaurant, it will find by himself the pages and return you the contact of the restaurant. We will add the page caching. Also, we will make also screenshot scraping. From a screenshot, we can, or an image, we would like to extract information and giving you the answer. Also, CAPTCHA solving and adding new web drivers. maybe Scrapey or Selenium, I don't know. We also created LLM models that will help you to write code on our library. So it's a fine tune on Llama 3. And basically he knows something about our library and we are continuing to developing it. And we are also developing and releasing our APIs in the next month. And we are looking for early adopters. And if you want to try our APIs, you can look at the QR. We will send you the link if you want later. Thank you for the attention.
Thank you for the great presentation and congratulations for all the work so far. So now we are open for a question from the public. So who wants to ask a first question? Let's go first here.
Okay, sorry. Also, I really like the project. I think it's a very interesting way to use LLMs. So good job. I was curious, do you think that multimodality actually, did you find that multimodality helped in scraping websites, or it didn't make any difference?
Yeah, actually, we still need to try it out using multimodality as giving a page screenshot as input. But we were thinking of using it. Also people just already use it for detecting how the structure of the page is. For example, web shops or also Amazon, they have the products really in a specific way. For example, there are there are regions where there are all the products, regions there are all the suggestions, and then we think that using multimodal models, we can create more efficient, let's say, scrapers, and for example, without needing for analyzing with the LLM the whole page, but understanding maybe where you need to point the LLM at, and that could be a future implementation.
So you're still testing it, right?
Yeah, we still need to try it, and we support actually multimodal models in our library, like Lava, Phi3, and Omni, GPT for Omni, which we used for describe images in websites. So instead of just asking for the textual content, which is already there in the page, we ask also for this describe images, and which can be really interesting for understanding what's happening on the page. Maybe it can also be interesting for the screenshot feature for understanding the ads, which are loaded dynamically inside a page, and it's not possible to retrieve them using getting them from a source tag, HTML tag. So a screenshot would be good for understand maybe what's the trends on that specific region.
Okay. Yeah. Can I also ask another one?
Yeah.
And the other one was, is there a pre-made system prompt before the user prompt that let's say it gives direction on what the LLM is going to do and stuff like that?
Yeah. The only one is to return a JSON format.
Okay, so it's just primed to...
Basically, let me show you the prompt that we give to the LLM. You can find it on the library if you open the...
Yeah, for example, we noticed that for local models, it's necessary to have the JSON specified before using the ScrapeGraph. And instead for maybe a GPT or a more powerful models, you don't need to specify it beforehand, for example, which, could be a feature or not. It depends on, it depends on you. This is how a node can be initialized and defined inside our library. And
this is the prompt that we give to the LLM for extracting information, and we import it in the node, in this node, and basically we use LangChain for creating the chain for the answer. And you can find it on ScrapeGraph helpers, and these are the models. But I think the most important is this one.
I see.
and also, yeah, they're similar to prompts you can find maybe LangChain Hub online. You can just pick one and the way the scraper works will change. So that's also one feature we're thinking about, to host our own schema or like prompts, and yeah, based on your needs, you can basically switch the prompts.
Okay, thank you.
Hi, thank you for the presentation. Quick question. I'm not sure I understood where the LLM part comes in. So for example, is it generating beautiful soup code behind the scenes and then scraping the web? Or is afterwards where the LLM is applied?
Okay. I will move here because I have the camera. Yeah, basically, there are different scraping pipelines you can use, pre-made. You can also create a custom made one for yourself. The most common one, as Vinci was saying, are a smart scraper, which is takes the HTML, parse it in some ways, and then gives the parsed document to an LLM. So the LLM will understand where are the content related to the user prompt. The one thing you were mentioning about generating the Python script, yeah, we're basically parsing the HTML in a different way to keep the HTML tag or the structure of the HTML actually in the prompt to give the LLM. So the LLM will understand where the content you need is in the page, and understand which are the tags and IDs and classes, and generate the Python script. Okay. And later we'll check the billing. We will check the billing later. I think it's his, so we're fine. Yeah, but yeah, yeah, of course you can use local models, so you don't have this problem with the API keys if if you have this.
The only part that use the AI is this one. All these parts are sequential, and they just execute code given by us.
Yeah, and yeah, the RAG node, of course, uses embedder models, and yeah, returning back to your question, like it generates that scraping pipeline generates a Python script, understanding the structure of the HTML, and then you will get a Python script that you can use for in another pipeline, for example, for starting scraping massively a website, for example, and if it encounters an error, it will call an LLM again to modify the Python script. Of course, we're working on making it efficient, and since it is an open source Python library, there are people like willing to help and contribute for this.
Thank you.
Thank you.
Okay. Other questions? Un attimo di lì.
Hi. I understood that there is a part that it's a RAG, and I want to understand if the RAG, like if with every prompt, with every question in the model, there is a scraping or there is a saving the data after the scraping the website in some place. Yeah. And the prompt, you can change every time the prompt, and you go retrieve the data from that place. And if it's you can retrieve like the information that you scraped beside the prompt, like can you have the scraping apart to use it in other ways? That's the demo.
Yeah, thank you. So initially, it was just every time it put chunks up the website or the document and puts in a vector database. And every time he had to call an embedder model to do that. And right now we also have a caching system on that part. So you don't need to, if you want to ask different questions on the same website, you don't need to, again, fetch the HTML and again do the RAG node, but you can just ask the question. It will go directly to generate answer. So it will retrieve from the vector database the chunks that most relevant for your prompt and understand, generate the answer, basically. So you don't need every time to do that. Okay. And yeah.
And
yes.
Just to get into scraping without the prompt, without question, and can you have the save data, or it's just like the only way to get it is actually to write the prompt and question the LLM?
So there are different ways. This one is one. And
it is mandatory to give the prompt, because if you don't give the prompt, the LLM don't know what you want from the website.
Yeah, but can you get just the information of the website that you already scrapped, like to save it somewhere, to use it maybe in a different way?
Yeah, we will add you. If you write the issue, we can figure out and maybe do it. Thank you.
No problem.
And also one of the, you share, okay. One of the next feature would be also for to answer you. Since basically our website is a hierarchical structure, we can basically study that structure, how it changes over time, to understand how is the website at a certain point, what it changes. Do we need to scrape the whole website, or do we need just to go directly on that tag, HTML tag? We're studying different ways to do it. A way which okay, yeah, better. A way we're thinking is by hashing the path of the HTML to understand basically if there are changes. For example, if you know that a specific the content that you want to get is in a specific subtree or substructure of the whole HTML, over time you will just need to detect if there are changes in that subtree and not in the whole HTML tree. So that's yeah, that's how we will do. Yeah, thank you. Yeah.
Let's go with the last question.
Okay. Hi. So actually, I have another question about the RAG, because it's not super clear to me how it works. So let's try to understand if I got it right. So basically, you store the chunks of the page in the RAG, and then you basically search for it for the most relevant part for your question, and you retrieve that. And so my question is, how do you store the information in the RAG? Because if it's just HTML, then you're missing how the order with the other things. Mm-hmm. And if it's some parsed way, you need to still keep, I don't know, the number of the rows, so you're kind of creating another HTML on top of plain text. So.
Yeah, so there are some libraries and ways to do semantic chunking. So maybe both in using semantic chunking on HTML, so you specify how you want it to be chunked. So if there are some maybe div structure, it will be stored in a database, all that div block, and yeah. Also, we're using RAG for. I mean, an important part of the RAG is the metadata. It understands really well by using a good metadata on the vector database, which can be, for example, or a description of what there's inside the chunk, or just maybe the path of the HTML. Of the HTML substructure. So, for example, different elements which have a similar path of the HTML will be stored close to each other, and yeah, that's a way. And also we are using RAG. We're thinking of using RAG for caching to scrape a whole website. So not just one page, but to go through all the pages. We're thinking about some smart ways to do it. But for example, if you already have all the website cached, maybe with every page in a document database, or yeah, in a more specific way, such as I was saying before, as a tree. Maybe you can beforehand understand where the information you need, in which page of the website the information you want is. So for example, if you want to go to find all the job posting inside a website, and you go just in the root website, so .com, and you ask for it, and it will understand that it will retrieve the page where there are the job posting, basically, and scrape that right away. But we still need to work on that. So yeah.
Okay, thank you.
Okay, thank you. And I guess there might be... There might be more questions, but they will be here also for the dinner, so you can reach out to them later. Yeah. Thank you very much.
Thank you. And of course, if you want to scan the QR code,
you can show it on the laptop.
Because we switch. Okay.
Yeah.
I will. Okay. Come to me, and I will show you on the phone.
And the streaming is closed.